Welcome everyone to this lecture on time series data analysis. Aiming on the integration of EViews with Python, we will look at the process of forecasting the monthly new housing starts series dataset. My main objective is to fit an ARIMA model, select the optimal model, and generate a forecast for the housing series dataset over a period of 12 months. To use the eViews external interface to Python, you must have Python installed on your computer. If you are interested in learning more about using Python with eViews, I have a helpful video that provides a basic overview. You can find the link to the video in the description below. To establish a connection to Python, you can open it by using the xopen command in the eViews command window. And this command enables the communication between eViews and Python, allowing you to seamlessly interact and exchange data between the two softwares, eViews and Python. Okay, first of all, let's load the necessary packages in Python. There are two ways to complete this. The first option is to write the required commands directly in the Python console, such as import numpy as a np, and if this package is not installed properly, you can install pip library in Python. Basically, numpy can be installed with pip. Numpy can be installed with pip package in Python. I'm using Azure Data Studio to manage the packages. For instance, you can go to Azure Data Studio, and here you can see that this is a Python attached to localhost. And if you want to install any packages in Python, you can go to manage packages, and under add new you can search for the required package. If you want to install any packages, like here I wish to install matplot library, you can simply write this package here and then search. Then you can see the package name and package summary, and then you can install. Once the installation is completed, then you can go back to eViews, and you can import the required packages here. Okay, this is the one way to import the required packages by writing in the Python console window. The second option for eViews Python integration is to use the external interface program by navigating to the File menu, File, New, and then click on Program. And this is the external interface program where you can write the Python program script. So this is the program, this is the Python script. So this command we use to opening a connection to Python, and then we can send eViews dataset to Python by using xput command. And here I am using housing series dataset. The range of this dataset is from 1959 to 1992, where we have 400 observation. So we can use this variable hs, the variable hs. So by writing this command, we can easily transfer a dataset from eViews to Python. And then you can use xon command. All program lines after that will be sent to Python directly. Then install the required Python packages to fit an ARIMA model and select the optimal model. So these are the required packages to analyze the time series dataset. Okay, then we can plot the time series dataset. We can create a plot of the time series dataset, and then we can write the label of the dataset. This is the x-axis, y-axis, and the title of the plot. And then we can use this command plt.show that will show the time series plot. All right. Then we can use statistical test to check the stationary in time series, and stationary is a very important assumption that we can check before analyzing the time series datasets. So you can use AD Fuller test to test the stationary, and then you can print the test statistic value and then p-value. So basically the null hypothesis of the ADF test is that the time series can be represented by unit root, that it is not stationary, which meaning that has some time dependent structure. If the time series data is not stationary, then you can use the log transformation to transform the series. So we check the stationary, and if the dataset is not stationary, then you can use the log transformation. So transformation if the time series dataset is not stationary. And then we can use AutoRima. The AutoRima function in Python is used to automatically select the best ARIMA model for a time series dataset, and this function selects the optimal order of the ARIMA model. And then we can forecast the future values using the ARIMA optimal model. And then similarly, we can plot the forecast values, future values. So this is the label for the original values. Then we have forecast values, X label, Y label, and then this is the title of the plot. And then we can show the plot by using PLT. And then we can close the connection, and this X off we can use to turn this mode off. So we can run all the program. This script we can run by clicking on run. Okay. So this is the time series plot with forecast values. So this is the forecast values, and in the blue color you can see that these are the original values. All right. So we can see that one by one. First we install the required Python packages, and then we plot the time series dataset, and then we check the stationary. And this is the ADF test to check the stationary, and here we can see that the value of the test statistic is very small and the p-value is close to 1, which is greater than nominal level of significance 10%. So p-value is greater than 10% level of significance, therefore we accept the null hypothesis. And after log transformation of the ADF test has changed, and the p-value is less than at 10% level of significance. So therefore we reject the null hypothesis, and we can say that the results are significant at 10% level of significance, but these results are not significant at 5% level of significance. Then we perform the ARIMA model using AutoARIMA function, And here we can see that we select the best ARIMA model based on the AIC value, which is minus 61.531. And similarly, these are the results of the best ARIMA model. And here you can see that we have log likelihood, AIC, BIC, and then the coefficients and their standard errors, test statistic value, and p-value. So based on this p-value, all of the coefficients are significant. So this is the procedure for time series data analysis by using EViews 13 Python integration. Thank you for showing interest in this video.